Hello everyone, so in this video I'm going to show you how to find the fundamental period of a periodic signal. So let's say you're given a signal x of t. Let's say you're told x of t is a periodic signal and you're asked to find the fundamental period of s of t, since x of t is a periodic signal. For simplicity, if x of t is a periodic signal, then it means x of t will be equal to x of t plus the fundamental period. Now, using Euler's formula, x of t is equal to a naught e to the j omega naught, right? Omega naught will basically be the radiant frequency of x of t, and a naught is the amplitude. And now x of t is equal to this, and x of t plus t naught is equal to, again, a naught e to the j omega naught t plus t0. Because if s of t is a periodic signal, then it means both s of t and s of t plus t0 will share the same radiant frequency, which is omega naught. So we basically set these two to each other. So we have a naught e to the j omega naught t is equal to a naught e to the j omega naught t plus t naught. Now this and this will basically cancel each other, and in order to simplify this, again, we do e to the j omega naught t, and now we break this down. So e to the j omega naught t, e to the j omega naught t naught. And this will basically cancel each other. So right now we have 1 to be equal to e to the j omega naught t naught. Now this is in polar form and this is in rectangular form, so there's a problem, right? In order for us to proceed, we would have to basically convert, put these two into the same form, right? So we want to make sure that 1 is also in polar form, since e to the j omega naught t naught is in polar form. So this is in polar form and this is rectangular form. Now we would have to convert this into polar form in order for us to proceed. So 1, right? Now, just for recap, we know that in polar, right, e to the, let's say, a naught e to the j omega t is equal to a naught cosine omega naught t plus again a naught a j is square root of -1, so omega naught t. So now we're saying this whole thing, right? We're saying this whole thing is equal to 1. This is in rectangular form and this is in polar form. Now we want to convert 1, which is in rectangular form, into polar form, right? So we're saying this whole thing is equal to 1. Now eventually a naught and a naught will basically cancel each other, because from both sides, right? Now in order for this, the whole thing, to be 1, then it means this would have to be 0, right? And you have to ask yourself, what value of omega naught will produce a 0 at this point, right? When omega naught is equal to 2 pi, the whole thing will be a 0. or when omega naught is equal to 4 pi, 0, that kind of thing, that will make this equal to 0, right? And while this is equal to 0, this will be a 1, right? So when you put 2 pi t over here, you're always going to get 1. So this, right? So right now we figured out that, we just pick one example. So omega naught is equal to 2 pi. Alright, so right now we know that omega naught is equal to 2 pi. So we have e to the j 2 pi t. So we just converted 1, it's just in rectangular form into polar form. So we come back to this point, right? So we say e to the j 2 pi t is basically equal to e to the j omega naught t naught. We should have labeled this, let's say omega j or something like that, because we already have this, but you get the point. So yes, so right now we take the natural log on both sides, right? We take the natural logs on both sides, and now when you take the natural log on both sides, you're left with j 2 pi t is basically equal to j omega naught t naught. Don't forget, our main interest is basically finding out what this is, right? So our main goal is finding out what the fundamental period is. So coming down here, we say j and j will basically cancel each other, and t naught basically be equal to 2 pi t over omega naught. Okay, so for any habitual periodic signal x of t with the fundamental period, with the radiant frequency of omega naught, the fundamental frequency will always be equal to omega naught. The fundamental frequency will be equal to 2 pi t over omega naught, right? And we always sort of equate t to equal to 1, so t naught is just equal to 2 pi over omega naught. Okay, so just for an example, right, let's say you're given a signal x of t to be equal to cosine of t, and you're told that x of t is basically a periodic signal, and you asked to find the fundamental period of x of t. Now from this right here, from this signal, you can tell what omega naught is, which is the radiant frequency. We know that the radiant frequency from this is basically equal to 1, right? So right now we just plug that in, and we're gonna get omega naught to be equal to 2 pi over 1, which means our fundamental frequency is equal to 2 pi. Again, you can apply this formula anywhere you want to apply it. Okay, so let's say you're given another example, x of t to be equal to cosine square root of t square root of 2t, and you're told this is a periodic signal, and you're asked to find the fundamental period. So in that case, again, you plug that in, right? So in that case, we know that omega naught is equal to what? The square root of 2. We just plug that in, and we know that fundamental frequency is equal to 2 pi over square root of 2. Alright guys, so with these two examples, I hope you sort of got in the gist of what fundamental frequency is all about, and I hope this further helps you understand this whole thing. And